All right, welcome to week six. Week six. We got a short week this week because I think Friday is off, and we're gonna. There's a couple big announcements. First of all, due to a student guessing a correct number in Discord last night, in fact, we had at least 10 people guess the number, so it was guaranteed to happen, I guess. I have extended the deadline on RTX on to Wednesday. I don't do this often. Don't expect it to happen again. It annoys me if students start relying upon deadlines to slack. However, I do sort of keep an eye on how things are going, and if I think people are working hard and could benefit from a little extra time, then sometimes, every once in a while, don't count on it. I'll do something like this. So, RTX on due on Wednesday at noon. I have graded all of the assignments that were done, and by done I meant kind of in the teens and above, and I awarded extra credit to them. I did accidentally double the point totals. So if you're excited because you got a 20 out of 10, I'm going to go through and fix that. You don't have a 220%, for the people that got a 22. I'm going to go through and fix that in a second. Yeah, it really is important to me that you all get this assignment done because this is really a good assignment. This is the first time I've done it, but at the same time, I've just been watching how you're asking questions and exercising some brain cells for the first time. It's good because I've been getting a lot of questions like, if I have a ray and a rectangle, does that function, and I want them to intersect, does that function go into ray or rectangle or main? And that's a great question, right? Because there's 144%. I'll fix it, Carlos. Sorry, that was a little too much extra credit for getting it done. But it's a really good question, and this is one of the reasons why object-oriented programming is considered more difficult to wrap your brain around than procedural. Procedural programming is what we do in CSI 40. In CSI 40, we learn if statements and for loops and functions, and basically main does everything. Start at the top of main, go to the bottom, call into functions. The brains are in main. And so in object-oriented programming, the brains are in the classes. And so it's a really interesting question, who should know about what? Should a ray know what a rectangle is? I don't know. Should a rectangle know what a point is? Probably. Maybe. Because at least the way that I did a rectangle, my rectangle is built out of points. It's got a bottom left point and an upper right point. So the rectangle class should know about the point class in that case. And so, when I was making my rectangle class, I made a function called isIn, which takes a point and returns true if that point is inside of the rectangle. And I use that for the map correctness check. Basically, I want to make sure that every corner of every rectangle within me is within me. Okay. So for every rectangle listed as a child, I go through each one of the four corners and make sure that each of those four corners are inside of the bounds of the big non-solid box. And so it made perfect sense for my rectangle class to have an isIn function because it knows about points already. But for ray rectangle intersection, I don't know. That's tricky, and people will disagree. I did mine in main. I just made a function. I made a global function in main that takes a ray, takes a rectangle, and does the intersection. Probably one of my former professors would have been horrified by that and disgusted and refused to acknowledge the fact that I am his equal in professorial majesty or something. I don't know. These days. Right? Because people, in all seriousness, people do actually have disagreements when it comes to object-oriented programming. How do you break it down, And this is the first time you had to write your own makefile. It's the first time you had to split your classes, split a file into different classes, header files, CC files. I did that for you in imaginary homework. I'm doing it for you again in your next assignment, but for this one, you had to do it yourself. And the reason why that was important is because if you have two people working on an assignment, if you split the files up, then one person could be working on rect, one person could be working on ray, and they don't step on each other's feet. If you're editing the same file, it gets annoying. You can merge things together and stuff like that, but it's annoying. It's just nicer to be able to just sort of partition stuff out like that and have one person just using the rectangle class and the other person writing the rectangle class, So the hardest thing was setting up GitHub. Yeah, GitHub's not easy. It's the industry standard, but basically, every major company that I know uses Git in one way or another. And all of them have like Git specialists that they basically keep on staff just to handle issues with Git. And even still, like, I've never known a major company not to have like a major problem with a repo at some point where they're just like, I don't know, it's screwed up. And they have to like rebase the entire thing and yeah, there's a lot of good things to be said about Git, but yeah, like I said, I've seen people just shoot themselves in the foot with it a lot, and so it's good. It's good that you're getting experience with it. Let's put it that way. Just be the GitHub whisperer. Yeah, literally, I have a friend that did that. Like, that was his job. Like, was just to like make sure that it worked, and then integrating the repos with the testing system, the continuous integration, stuff like that. Yeah, that's a job, and it's a good job and a very popular job, right? Because we all build stuff, and you need to track data. You have to track your changes over time, and you have to coordinate with other people, and having an expert in that is like every company needs one. You need at least one GitHub whisperer per company if you're a big company, or per team sometimes. Okay, so Markdown Master, yeah. Can we go over how to use the vectors of maps and shots in operations 6 and 7? A brief overview. Ada, you want to tell them how to intersect an array and a rectangle together? You want to go through the math for that for them?
No.
Okay. Thank you. Can you hand me my... oh, sweetheart. Can you hand me the tablet, girl? It's on the ground down there. Vectors of maps and shots. And where's the stylus? Ada? Stylus is on the ground. Oh, thanks. Ada, you give me the stylus.
There's no stylus.
Look around. Oh no, I got it. Here. It's right here. Okay. So which one is 6 and 7? I don't remember off the top of my head. Hesterberg. I'll answer some questions about RTX, and then we'll move on to bigger and better things. 6 is overlap. Okay, yeah. So there's a couple different ways you can do overlap. Okay. Get rect. Okay, sure. So here we go. Here's a rectangle. Here's a rectangle. I know that rectangle 1, rectangle 2. Okay. This is x minimum, and this is this guy's x maximum. If any of the rectangles' minimum is greater than the maximum, they don't touch. Right? Oh, are you talking about two rectangles overlapping, or like the one where you're seeing if a map, like the map check one? Pulling from vector map check. Okay. So for that one, what we have is we have a vector of ints called children, and that is everybody that's within my zone, right? So I'm rectangle 0, and I've got rectangle 1, 2, and 3. Like, so the vector contains 1, 2, and 3. And so what I do is I just grab, remember, the children vector is a vector of integers. It's not a vector of rectangles. That was something that a lot of people got screwed up on. It's just an index into the vector of the boxes rectangle, or whatever you want to call it. And so basically this rectangle has a children vector of ints, and it's just 1, 2, and 3. So what I do is I go into the world, when you load the map, you get a vector of rectangles back. And I just pull out each of these. I pull out, so I say for int x in children. So for every int x in children, I do a overlap check between me and x. Well, I've run out of room, but boxes x, something like that. You can't really read that, can you? Hang on, scroll down. So I do this. So I say for every imp. So for every integer x in my children, I do an overlap check between me and x, basically. And you can pass in you pass in the list of all boxes or something like that. So this is like your vector of rectangles. This is what was loaded from load map. So you can pass that in. This is just an index, my index, that's the kid's index. And so basically you do an overlap check, and if they don't overlap, then you die. Okay, so the question is, so every int in the vector of rex for me, right? So whatever index I am, like I'm index 0 in this example. So it passes in 0, and then I've got a vector of children, 1, 2, and 3, so it'll pass in 1 the first time, 2 the second time, 3 the third time, and doing an overlap check for each of them. If any of them stick out, like this one does, and what you do to see if it is inside is you just go through each of the 4, that's a kind of a missing corner there. You go through each of the 4 points, and you say, is this in? So I have an is in function, and I basically just say, is that in me, is that in me, is that in, is that in? If any of them are outside, then it violates the condition that all children rectangles have to be inside the parent rectangle. And so that's why I have a is in function in the rectangle class. So basically for every child, I check all 4 of the corners and make sure that they are inside of the parent rectangle. Does that make sense? So, yeah. Yeah, all 4 corners have to be on the inside. There's no possibility for like, all 4 corners to be on the inside. Like there's no like curved, there's no curved edges, right? So they can't stick out. So if all 4 corners are on the inside of the parent, then the rectangle is inside of the parent. So, and then what was the other one you wanted to question about? We're supposed to be vetting them as we add them to the list or after. No, you don't do the overlap check until you do the overlap check like command. So like, and that's usually how it works in games. Like you normally just kind of assume the map that you're given works because it's very expensive at times to vet a map like that. So what you do is just as part of your workflow, when the artist hands you the Grand Canyon map, you run a map check on it first and just verify that nothing's violating the rules like this. And then you just you run it when you get it from the artist, and then after that you just like, all right, cool, it's fine. Like you're making an arcade game or something. Like there's no risk that a player is gonna make a new map, right? They're all on disk, right? So I'm thinking of Hydro Thunder, of course, which was a game that my friends made. I was up at Big Bear a couple months ago, and they had Hydro Thunder there. I'm like, do you guys know Hydro Thunder? I got to play it before it came out. This is like one of those arcade games that you'd always see in like movie theaters for some reason. I don't know why it was so popular in like movie theaters, but like you'd always go to a movie theater and there would always be like this boat racing game, and yeah, that's what it looks like. Yeah, my friends worked at Midway, and I'd go out and visit them occasionally. Had one of them give a guest lecture to my game development class last summer. Yeah, so I got to go out when this was still just like on a table, and I got to see their maps and their workflow and the Grand Canyon. This looks nicer than I remember. Did they remake it? They must have remade it. This does not look like. Yeah, this is what it looked like. You like count the right, like straight line. Yeah. This is way too nice for what I remember. Okay, anyhow. So like when you do that, there's a workflow, right? The artist will produce, a map, and then they'll send it to you. And so yeah, you vet it once when you get it. You're like, all right, cool, just to make sure. And then after that, you don't. Always in the movies and Dave and Buster yet. And then after that, you just leave it alone. So to answer your question, Portnoff, yeah, you don't do it when you load the map. You just assume that it works, but there is that map check function just in case you want to vet it. So, RTX Hydro Thunder. Yeah, that's cool. All right, shots fired. Oh, yeah. So for the option 7's the tough one, right? But if you've got everything else done, it's not too bad. So what you do is you say for every ray, and this is going to be a const reference, ray called shot in shots. So for every shot and shots, for every this is going to be a const rect. I'm not going to write it all out. I'm just going to write rect. Okay, you guys know what I'm saying, right? So for every rectangle named box in boxes, then you do the ray rect intersect kind of thing, and you pass in shot and box. What are you drinking there, girl? Pass in. What is that? Pass in shot and box, and then you like.
This is what I'm drinking.
If it hits,
This is what I'm drinking.
It smells like fruit juice or something, but it looks like water. And then if it hits, you basically I don't know, write it down or something. Oh yeah, ew, you. You're drinking water out of a Twizzler or something.
It's not a Twizzler.
Okay. So that's the general idea. So basically, for every shot, for every box, and this is an order. This is not a great algorithm, right? This is the Kearney was too lazy to make a giant map, so just do it the lazy way algorithm. For every shot, for every box, if it hits, then write it down, and whichever box got the most hits, that's the one you say wins. Yeah. Okay. So notice how I'm not doing the BVH traversal here. Yeah, it's because I got lazy. So you don't have to use the you don't have to use the BVH tree structure at all for this because I got lazy. So take the W. Don't. This assignment, is enough work as it is. If you want to do it properly, good on you. But just take the win. Okay. Any questions? I was thinking of making children a vector. No, just a vector of ints because those ints are going to be they're going to appear at some point, right? That's why I'm using integers rather than pointers. It's actually fairly common to do something like this. It's called like an object pool, where like if you want to refer to another entity in the world, every entity just has its own unique ID, and that's just an index into a vector. And so basically, if my child vector is 50, my child rectangle is 50, then I just write down 50, and then later on, if I need to look it up, I just go to index 50. It's actually.
What class is this?
This is my data structures class. Okay.
How many classes do you have today?
About 3. That's my third one today. One in person.
This is your third?
This is my third one. Okay. So,
Wait,
any other questions about RTX?
What was your in-person one?
My in-person one was in person.
Oh, yeah, you just did it.
I just came back from it. I freaking love that game. I remember this. People are typing but not saying anything, so we good? We good on RTX on? That's the general structure. I made a vector of ints to keep track of the hits. So every time you get a hit, I would increment a count by 1, and then I'd run through the vector and just see which one was the highest. Again, there's better algorithms for doing it, but I got lazy, so just do the slow, inefficient algorithm and don't worry about it too much. Okay, ups. All right.
Yeah.
So, actually, I'm going to need this.
Can I ask, can we play Don't Starve together with your students?
Maybe. We'll see.
Yep.
Okay, so if that's it for RTX on, then we're going to talk about the next homework assignment. And there's one thing we need to talk about before we do the last homework assignment. There's one piece of the puzzle left, and that is delete from the middle of a linked list. So let's come back over here. We've done push front, push back, pop front, pop back. There's only one case we need to really worry about now, and that's deleting from somewhere in the middle. Okay? So let's say we've got 10, or 12, I guess in this case, and 21, and scroll down, 37. And we're doing a doubly linked list because singly linked lists are terrible. They really are. Like there's no benefit to a singly linked list. Some people just, I don't know. Some people use them, I guess. I've literally never used forward lists ever, except maybe as a demo for students or something. Okay, so we've talked about how to delete from the top. We've talked about how to delete from the bottom. We've talked about how to add to the top. We've talked about how to add to the bottom. There is one case left, and that is working somewhere within the middle. Now, good news. If you know that you're somewhere within the middle and you got a parent, you got a child, do you have to worry about maintaining the invariant for head and tail? Do you have to worry about these things? If you know that you're just in the middle of the list, you're not at the top, you're not at the bottom, is your code going to have to involve the head or the tail in any way? What do you think? There's at least 3 nodes in the list. You're somewhere in the middle. We're going to be deleting 21, let's say. Okay. Are we going to have to maintain the invariant for head and or tail? There's a lot of people typing. Oh, shoot. No wonder nobody's saying anything. I had scrolled up. There we go. No, you are. I was just like, it's so dead on Discord. Okay. Yeah. So, no, you do not have to, like, heads up here, maybe. Or might even be higher up, who knows. Tails down here. If we're deleting the middle here, yeah, we don't have to special case anything for maintaining these invariants. So one of the nice things about deleting from somewhere in the middle of a list is that it's actually really simple. There's less cases to worry about. Okay. You'd have to traverse the list to get to it. Yeah, and that's what you're going to be doing for your homework assignment. So can you do everything with a singly linked list compared to a doubly linked? Yeah, but sometimes you do an extra order in traversal. Like if you're here, like let's say you're here and you want to delete it. If you had a singly linked list, then you have no way of getting the parent, right? So if you're going to delete 21, you have to make this pointer fixed. You have to have it point down at 37. And so with a singly linked list, a lot of times you're stuck doing an extra order in traversal where you start at the top and go to the 12. And it's just really annoying. There's just really no benefit to a singly linked list. So, is that the benefit of a linked list in the first place? The benefit of a linked list in the first place is deleting from the middle. Yeah, it's the only data structure, common data structure, that you can delete from the middle in order one time. In other words, you've got order 1, insert, and delete in the middle. If you have a pointer there already. And that's the big problem, is that in order to get a pointer there, you usually have to do an order in traversal to get there. And so it doesn't help very much usually. Because in order to delete from the middle, you have to start at the top and go next. Oh, we found 21. And then you could delete from 21. Cool. But it usually just doesn't help. I just had a classroom observation last week, and the person who came in to give the observation said, it would have been nice if you had talked about some examples where you'd used singly linked lists before. And it's just like, I really don't use them. Especially singly. Like doubly, very occasionally I'll use a doubly linked list. Singly linked list, it's like, good point. Yeah. Okay. So does doubly linked have? Yeah. So a doubly linked list has a previous pointer and a next pointer. So that's the only difference. So we've got a previous pointer coming out of 21. So 21's previous is pointing at 12. 21's next is pointing at 37. 37's previous is pointing at 21. 21's previous is pointing at 12. So it looks like the following. Where is my thing? And Mitchell, yeah, doubly linked lists are just better. Let's put it that way. Keep things simple. So for your homework assignment, you're going to be doing a doubly linked list. And so this is what it looks like. So you're going to have a previous pointer and a next pointer. Okay. And even though that looks like it's more code and more, things, it's actually a lot nicer because you can just go upwards and downwards. And if you delete something, you can just fix up the pointers, and it's just actually a lot less code to write, believe it or not. All right. Any other questions? How soon will the recording be posted? I'll upload it as soon as I'm done here. Okay. All right, so here we go. So if we wanted to delete 21, call out what needs to happen. And everything, I'll do this in white. Everything I do in white is going to turn into a line of code. Okay? What invariants are. Invariants are things that must always be true for a class. So for example, for linked list, an invariant would be, there's two invariants that we usually care about, maybe three. The first invariant is the head always points at the top, or null or null if the list is empty. The tail pointer always points at the last element in the list, or null if the list is empty. And sometimes you have a third, which is size. You keep track of how many elements are in the linked list. Just because it's easier to, like if somebody says, what's the size of the linked list? It's a lot easier to just return a value than it is to do an order n traversal where you count all the elements in the list. It's just nicer to just keep that number around. You don't have to do that. Depending on the implementation, some do that, some don't. But if you want to keep track of that, that would be an invariant. So you'd have an invariant saying the size member variable always has the accurate count of how many people are in this list. And this is why we make classes. Classes are really there to preserve invariants. If anybody could just be like list list points to size, if anybody could do this, they could just break our counter. You know what I mean? I can't guarantee you that the size is accurate anymore, right? If anybody could just say list points to size equals 7, I can't guarantee you that I have an accurate count anymore. So that's why we use getters and setters. And if everything goes through the interface, then every time we delete something from the list, I could decrement the size. Every time I add to the list, I can increment the size. And I can guarantee you the size will always have the right number in it. Does that make sense? This is why we do ADTs instead of pods, right? With a pod, everything's just a public member variable and you can just set it, right? And you just break it. And you have no guarantee that this number is actually accurate in any way. Does that make sense, Carlos? And so really understanding invariants is understanding object-oriented programming, because that's really what an object is about. An object is about protecting an invariant. Okay? If you don't have any invariants, it could probably be a pods, right? Like the point class that I made. I'll show you the answer. Okay. So for my point class, it's a pod. It's a plain old data, right? It's a struct. There's no privacy. There's no data privacy. And the reason for that is because all it is just it's just an X and a Y. What invariant do I have to maintain? Nothing. What values can X and Y be? Anything. There's no contract. There's no guarantee that I'm giving you. With like the rectangle class has some invariants. The minimum point must always be less than the maximum point. The corners must, you don't need to know about that. Solid rectangles cannot have children. Non-solid rectangles must have children. There's these invariants that I enforce in my code. And so I've got a min and a max, and every time you try reading or writing to them, I always verify that the maximum corner is always bigger than the minimum corner. So if you have does that make sense, Carlos? Like it's a contract. Like I'm guaranteeing all 100% of the time that the minimum corner of a rectangle is always going to be less than or equal to, or actually just less than. The minimum corner is always going to be less than the maximum. Always. If there's a contract that you guarantee, that's when you use a class with private member variables, public interface, getters, setters, constructors. When you don't, I don't care. Like you can set X to anything, you can set Y to anything. There's no contract, like there's no guarantee. They could just be anything. I don't care. Then I do a pods for that, and there's nothing wrong with the pods. It's just, you know. And so I got here. I have some member functions. You know, I can compute the distance from one point to another. I can tell you if one point is less than another point. I can see out a point and I can see in a point. But because there's no invariant, it is a struct. A little philosophy here. It's kind of a philosophical point. But any questions about that? Y'all understand? Okay. So, we were talking about this. And so we don't have to maintain the invariant for the head and the tail because we're deleting from the middle. We're not guaranteed we're not going to be moving head or tail around, so we're fine. Okay, so what lines of code need to run here? What lines of code need to run? We're going to be erasing 21. We're calling delete 21. We have a pointer to 21 already. We'll call this pointer temp. We've been, if you remember that for loop I gave you last time, we're like kind of going down the list, and we're like, hey, if you ever find person 21, erase them. So we're going down, saying something like, you know, if temp points to data equals 21, then we're going to have some code here, and this code is going to erase it. Any ideas? What do we need to do to erase 21 out of existence? Is Discord frozen again, or are you just not answering? What needs to take place here? Yeah, so there's this pointer here. Okay, so if we erase 21, right? That's probably a good place to start, right? Delete temp, right? And we'll do that last, actually. But if you delete temp, see, everything you draw in ink turns into a line of code. So we're going to be deallocating the memory pointed to by temp. Which pointers need to be fixed? Which pointers are now pointing at unallocated memory? What do you guys see? There's 2 pointers that need to be cleaned up now. Temp is, yeah, but temp's about to go away, so we don't care about temp. In the data structure, but good answer, yeah. There's 2 pointers that need to be fixed. Yeah, so 12 is going to need to point to 37, and 37 is going to need to point to 12. That's how you fix a linked list. When you delete something from the middle of it, you're going to fix the pointers around it. So yeah, so this pointer here and this pointer here, if we erase 21 from existence, these 2 are going to be pointing at nothing. So they need to be fixed up. So what we do is we say this. We're going to make you point to you, make you point to you. Every bit of ink you draw is a line of code. And so this is temp. Temp points to next is this fellow here. And temp points to previous is this person here. Okay. So what we do is we say temp points to next points to previous equals temp points to previous. I don't know if you can read the handwriting there, but temp points to next previous is equal to temp points to previous. Maybe just type this out. My handwriting's not very good today for some reason. So there's 3 things that need to happen. We need to delete temp. We say temp points to next, that's 37. 37 is another name for temp points to next, right? So 37's previous pointer needs to be set to this fellow, 12. Another name for 12 is temp points to previous. So temp points to next, aka 37. Their previous pointer is going to be equal to temp points to previous pointer. And temp points to previous, that's miss 12 over here. 12's next needs to point to 37, who we call temp points to next. Temp points to previous points to next equals temp points to next. And this is why we draw the things out and give them names. Okay. Now there's one problem with this, and we delete temp last, right? What is the problem with this code? If you have address sanitizer on, it's going to write. This code might actually work, but if you have address sanitizer on, it's going to throw an exception and kill your program. And why? After you delete a pointer, can you dereference it? Can you dereference a pointer after you've deallocated it? No. So you cannot say, "Hey, go to temp's memory and use it." You can't do that after you delete it. So we have to do that last. And there we go. This is all you need to do to delete from the middle of a linked list. 3 lines of code. 1 to delete, 1 to fix that one, 1 to fix that one. Good to go. Okay. If you want to insert to the middle of a linked list, then it's very similar. So let's say, do you want to insert before 21 or after 21? I don't really care. Let's pick one. Give me a number to insert. Before or after 21? Before. Okay. So we got a pointer here at 21. We're going to insert before it. -1. Okay. So if we want -1 to enter the list here, there's a couple things that have to change, right? These 2 pointers are both going to have to change. So this one here is going to come here. This one here is going to come here. And then we need to add 2 more in like this. So it's a total of 5 things. We have to allocate RAM for this, and then there's 1, 2, 3, 4 pointers that have to be set. So 5 lines of code total, or less if you do it in a constructor. So this is what we would call delete from middle. And then we'll do another one. I'll just copy and paste this. And this. Huh. Okay, whatever. Insert in middle. And notice that for this one, we don't have to do anything involving like head or tail or any of that stuff because we know we're in the middle. So if you know you're in the middle, then you just, not worry about it. Okay, this one out. Insert in the middle. So before temp. All right, so we have a pointer here somehow. However the pointer got there, doesn't matter. We're going to be inserting before it. Okay. So we're going to say linked list pointer new guy is equal to new linked list. And we're putting what in? -1. So we're going to initialize it to -1. His previous is going to be temp points to previous. Right, this is temp points to previous. Is this one? And that's temp. Okay, so we don't worry about 37 at all. It's not involved. Okay, so his previous pointer is going to be temp points to previous, and his next pointer is going to be temp. So that's 3 of the lines of code. Then temp points to previous is next, so we have to do this one. So temp points to previous, their next is going to be set to the new guy. So temp points to previous points to next is equal to the new guy. And then temp's previous is going to be the new guy. That's it. That's inserting in the middle. And that's it. That's all the things you need, because we've talked about pushing at the front, pushing at the back, popping off the front, popping off the back, and now we can insert and delete from the middle. That's all the cases. That's everything that you basically want to do with a linked list. We've talked about traversing it, so you can print out everything in it. You can also traverse a linked list to search it to see if it contains a number or things like that. So let's talk about your homework assignment. We've got 30 minutes left in class. Okay, so your next homework assignment is called EU4. If you're still working on RTX on, keep working on that. I pushed this out for the students that got it done already and are eager to start a new assignment. There's also a Zybooks. There's also a Take 2 on the competency exam up as well. Take 2 is only for the students that did not pass the first one. So there's your second take on it. Higher score wins. Basically your higher score replaces the lower score. If you want, you can take it if you pass the first one, but you're kind of wasting my time making me grade it. So, if you want to do it, but don't take it just because you see it on Canvas, right? If you got a 3 or a 4 on the first one, you've passed. You're going to get a 4 out of 4. Don't worry about it. Okay. Too late. You already took it. It's fine. It does take me a little bit of time to grade these things. So, just don't take it just because you think you have to. All right. So EU4. Let's talk about this. So this is an assignment using linked lists and sort of a valid. This is actually a case where I would actually use a linked list. And so that's why I give this as a homework assignment, because there was a actual application where I had something sort of like this, and so I actually used linked lists. Like, they're not 0%. Okay. All right, so let me show you my directory first and run it for you. So when you run it, there's actually two things that are there before you actually run the program. The first thing tests your node class, and for this assignment, you're going to be making a separate node class and a separate list class. And so the list class will use the node class to make a list out of it. And the reason why we do this is because the list class can track things like how big the list is, right? And it tracks things like head and tail, rather than it being in main where it just doesn't belong. And so you're going to build a linked list node class. And after you build it, you're going to run this. And what I've done for you is I've built a sort of unit tester into the code itself. And so what I do is I try basically every possible combination of thing with your code, calling getters, calling setters, making sure that they all work. And if it doesn't work, then it will print an error message saying you're not handling the case where you pop from an empty list or something like that. So for the node class is pretty simple. All of you should be able to do the node class pretty quickly. It's just making constructors, getters, and setters. Once you get it done, students in my previous class had it done within class. You run the program, you hit test my linked list node class, all tests passed. There you go, you got a point. Yay. Okay. After that, you make the list class. The list class is a little bit more involved. But basically, it's all those functions that we've been talking about over the last week or so. Push front, pop back, push, et cetera, like all those kinds of things. And then when you think your list class is done, you run that, and it runs through all these different tests. It's pushing things and popping things and trying all these different things, trying to see if your code has any bugs in it. And so you're welcome, by the way. Like, it's a pretty, I'm actually pretty proud of it. Like, it actually does a pretty good job finding bugs in your code. So before you even get around to running the software for this, you must have a working node class and a working list class. And once you've done that, then and you've run the test, then you're confident your code's good. And so your actual application code will be good also. Make sense? So cd to EU4, then ll.h. So this is what you're given. For this one, you don't have to do a makefile. I've given you a makefile. It turns on address sanitizer for you. You don't have to write a lot of the stuff. I made the skeleton for you. This is a partnered assignment, by the way. If you want to have a partner, work on a partner. Don't tell me. Don't make any groups on Canvas. This one is like a low-key partnered assignment. The node class and list class would be separate .h files. Normally, I put them into the same file. So they're just all in ll.h. And the reason for that is because normally the node class would be actually inside of the list class, but I have it split out separately so that you can kind of test it a little easier. Group size 1.5. Yeah, if you want to have a partner, if you want to work with somebody, the rule that I have is just at the top you say, I am working with Shook. Okay. And when the cheat checker picks up the fact that Portnoy's code and Shook's code is 99% the same, what I do is I go into the code and I look at the top of the file, and it's like, I'm working with Shook. Okay, no problem, right? There's a bigger problem if 7 people have the same code. I am working with Shook, and Shook's code says I am working with Holman, and Holman's code says I am working with Mora. You know, I'm like, no, it's a partnership is bidirectional, not unidirectional. Damn you, graph theory. Okay. I'm working with my class. Yeah, just one partner, bidirectional relationship. It's a linked list. Our partnership is a linked list, right? So you just, yeah. Okay. So, yeah, do you all understand? If you work with somebody, just put at the top of the file who you're working with. I should mention that here. If you have a partner, put your names here. Okay. Okay. So, what you're going to do is everyone's graded individually. There's no group grades or anything for this one. It's just, you know. Okay, so first thing to do is to make a node class. So a node is an individual element. One of those little balls that has the pointers coming out of it. One of those things is a node. And I'm calling it LL. I guess I could have called it node. Maybe I should have. I don't know. I'm calling it LL. I don't know. And so this is a doubly linked list. It's got a next pointer. It's got a previous pointer. And then it's got a data payload. In this case, it's going to have a string and a cost, which I'll go over in a little bit. So the first thing you should start off with is just writing the constructor, writing the getters, writing the setters. That's it. You should be able to knock this out like pretty quickly. Like it's pretty straightforward. Some students are kind of confused on the syntax. Like, you know, if you're returning a linked list pointer, do I return star previous? You know, like some students were asking that in the previous class. Nope. It's just going to be return prev. That's it. You know, you're getting a pointer. Do I have to dereference something? Or, nope. For this one, you're going to say next is equal to new next. Okay. Remember, pointers are just integers. So if you just treat these things as integers, just copy the values in, return the values out. Don't ever, LL Cool J, yeah. Don't dereference anything, you know. So you should be able to do this pretty quickly. All right. So once you get that done, you're going to run the testing thing. And here you can see the tester that I made for you all. Don't modify the function. Just leave it alone. And it's going to run your code and pass things in. And if something, if something happens, like you'll add a negative cost to be set. Your code should set a negative cost to 0. Yeah, so there's some rules that you'll see in the README file. Like you can't have a negative cost. So if you try setting a negative cost, then you need to cap it at 0. You set a floor at 0. Okay. And so if you fail something, if you're like, oh, I didn't know that, then the thing will actually give you just a nice error message, and it'll tell you, your default constructor doesn't work, your 3-parameter constructor doesn't work, your 4-parameter, so it'll tell you. It'll tell you what you did wrong. Okay. Then after that, you're gonna start working on. So comments and variable names don't really matter. What do you mean? They don't matter. If you add white space or comments, will it throw off the cheat checker? I see. It's a trade secret how it works, but yeah, changing variable names, changing white space, changing comments, things like that, don't fool it at all. So it's actually it's reasonably aware of C++, and so if you want to cheat, it's proprietary software. Yes, if you want to cheat, you have to substantially rewrite the code. So just write it yourself anyway. Okay. All right. Replying to Portnoy's gotcha. Yeah. So yeah, if you like change a variable name, it doesn't. It literally makes no difference to the cheat checker. Okay. Okay. So you're gonna make after you make the node class, you're gonna make the linked list class, and this is gonna maintain the head, the tail, the size. These three things have invariants. You know, class invariant. So good. It's good to write these things down, right? Number one, head must always point to the first element in the list, or null pointer if list is empty. Number two, tail must always point to the last element of the in the list, or null pointer if the list is empty. Number three, size must always have the accurate count of how many points are in the list. So it's your job to preserve these invariants. Every time you do a push, every time you do a pop, look at the invariants, make sure that your code is handling them all properly. If you delete the last element of a list, make sure that head and tail get set to null. That kind of stuff. Size would be static? No, it's not a static. You can have multiple lists, right? So, in fact, for this assignment, you will have two lists. And if you use a static variable, then they'll share the size, which is not correct. Okay, so you're going to make a constructor, destructor, getter, that kind of stuff. And when you're done with it, then it's going to run through all of these tests. I went to a significant amount of effort for you all. Just so you know, these are all tests that I made just to make sure that your class is correct. And so it tells you, like, if you screw up on any of these functions, it will find it pretty certainly. And it builds, you know, it does push back and push front and alternates them and pops things, and like, I wrote a lot of tests for you guys. So it will find bugs in your code if you have them. And once you get to the point where you're passing the second thing, where it's like, you know, test my list class, if that passes, then you should be pretty happy that you've got a working linked list class. Okay? Yeah, you're welcome. You're welcome. So what we normally do in this class with like the input tester is something called end-to-end testing. So basically, it runs the entire program, it feeds an input, and it measures the output. But what I've done for you here is something called functional or unit testing, where I'm basically testing not the entire program, but just one function at a time. And these are like two different philosophies towards testing. They kind of go hand in hand with each other. And what I do with this is I'm really making sure that your insert at front and insert at end and everything is correct, right? And in professional software fields, you will do a lot of functional testing as well. Like, for example, if you want to do like a function to compute how much interest you have to pay on a loan, you know, you would sit down by hand and calculate, okay, if we have a 5%, you know, compounded monthly, or you know, this much principal, this much, you know, this is how much interest you pay. And you make like 10 of those cases you do by hand, and then you create a functional test. And so you've got your function, you pass in the principal is 100,000, a down payment of this, and interest rate of this, and 30-year fixed rate, whatever. And then it returns, you know, this number, and you verify that the numbers match up. And so that's called functional testing. And in pretty much every major company that I'm aware of, they do testing constantly. So if you change your program and you break a test, you're like, oh shoot, oops, you know. So anytime you make a change, you can be confident because you rerun the tests on it. You're like, oh, I didn't break anything, and that's a good feeling. When you have a big complicated code base, you make a change, you're always worried, like, is this going to snap something over here? I don't know, you know. And so you make a change, you still pass the test. You're like, all right, cool. I feel confident that I didn't hose, you know, my code base. And so this will give you a little bit of familiarity with unit testing. Okay, so now let me show you the actual program. So after you got your linked list class working, what you're going to do is you're going to make an AI for Europa Universalis 4, which is why I call it this, but it's a very simple AI. So if you are invariants functions? No, no, no. They're not. Yeah, thanks, Mr. Singh, for reminding me about that. If an invariant's not really a function. An invariant is a rule that must be true, and all of your functions must work together to preserve that rule, right? So if you have a rule that the size always has the number of elements in the linked list, if your push front and your push back and your pop front all do it, they add one or subtract one, but your pop back doesn't, you've broken the invariant. All of the functions have to work together to make sure that the invariants are being updated. Every time you add one to the linked list, it should go up by one. Every time you delete something from the list, the size should go down by one. And so it's a rule that all of your functions enforce, and it's a contract that you make that the size will always be accurate. Head will always point to the front, and all of your functions kind of work together to guarantee that to be true. Okay, so this is vaguely related to a video game called Europa Universalis 4. It's not really related to it, but I like calling it that because it's funny. So what you're going to do is, let's say that you're a country and you're thinking about in the video game, right? And you're thinking about invading people. So let's say that you've got 120,000 soldiers like that, and there's some provinces that you could invade. What the AI is going to do, it's going to have a priority list of all the targets that it can invade, and it's going to invade the highest priority target that it has enough soldiers to invade. That's what you're doing. So let's add a province to invade. So let's say, I don't know, Crimea. And it takes 10,000 soldiers to invade Crimea. And then let's add another province to invade, like Ukraine. Might take 100,000. And then every time you add a province to possibly invade, it gets added to the end. Okay? Too soon? All right. It's too topical. So let's say invading Paris. There you go. So Paris takes 100,000 soldiers, and Berlin takes 50,000 soldiers, and we'll add a high priority. High priority provinces go at high priority to invade. High priority goes at the top of the list. Regular ones go at the bottom of the list. So it's push front, push back. Okay. So high priority would be, I don't know, Finland, and it will take 500,000 troops to invade Finland. Okay, so if we print all the provinces, you can see that I did a high priority invasion of Finland, so it goes at the top of the list, and then I did Paris first, then I did Berlin second. Now I've got 120,000 soldiers. So if I hit invade, like this, Winter War, yeah, very good. So if I hit invade, what it's going to do, it's going to go through the linked list, and it's going to find the first province, the highest priority province that we can invade. We have 120,000 soldiers, so if we hit invade, then it deletes Paris. Do you see that? We have 120,000 soldiers. We do not have enough to invade Finland. However, we have enough to invade Paris. So it costs us 100,000 soldiers to do so. We have 20,000 soldiers remaining. If we print the provinces, you can see that Finland's still there, Berlin is still there. If I try invading again, I don't have enough soldiers now to invade anyone. Nothing deleted. Okay. Can you annex and invade? Yeah, I'll explain annexation in just 1 second. But that's the general idea, is that you build up a linked list of potential targets, and you have a cost as to how much it will cost you to take them. And then you have a sort of budget of soldiers, and what you do is you find the highest priority target you can invade. When you hit invade, you run down the linked list, searching for somebody we can take. Once you find somebody you can take, you delete that node out of the list. So this function is going to involve push front, push back, and delete from middle. Yep, that's it. Push front, push back, and delete from middle. No pop back, no pop front, no insert in the middle. Push front, push back, delete from middle. So, yeah. Functions we talked about today and then over the last couple days. Yeah, kind of like buying the most expensive item from a market, given your budget. Yeah, and that's the kind of thing that I was actually using this for realsies. This is a toy thing. But I was writing code where I just had a bunch of like options that I wanted to do, and I had them sorted by priority, and then I would actually do multiple ones, right? So it'd go through the list and be like, okay, I could afford this one, and this one, and it would go through and pull them out and delete them. And a linked list was the right data structure for that because you're doing multiple deletes from the middle, and so it's actually substantially faster than repeated deletes from the middle of a vector or whatever. Okay. Supply chain logistics here. If you delete a smaller faction, does it add to your army? Nope. It only goes. Your army only goes down. This is not like a video game like Risk or something like that. It's purely a matter of like there's a cost to a province, and when you invade it, it costs you that many soldiers. So, for example, if we added 80,000 more soldiers, we're up to 100,000 now. And if we print all provinces, you can see we still don't have enough for Finland, but we've got enough for Berlin. And so if we invade, then it deletes Berlin, and we have 50,000 left over. It costs us 50,000 soldiers to invade Berlin. Okay? And we still don't have enough for Finland. Finland's impossible to take with the... what was his name? Simo, the White Death or whatever. Okay. Now, diplomacy is exactly the same as invasion, except you can delete multiple provinces at the same time. So it's exactly the same. You're going to have two different lists. You're going to have one list for soldiers and one list for like military targets and one list for like diplomacy targets. Okay? So let's add a province to annex. Lithuania, and that would take 1,000 diplomacy points, like how much favor you have with the United Nations or something. At a province to annex Estonia, that would cost 20,000. And so we've got here Bob, Lithuania, Estonia. Let's add a high priority. That'll come at the top of like, I don't know, Quebec or something. And that would cost 2,000 to annex Quebec. So you can see here, Quebec came out at the top of the list. Now, let's add some diplomacy points here. Let's add 4,000 diplomacy points. And so now we've got 4,000 diplomacy points. So when we hit annex, what it's going to do, it's going to go through the list. And we start at the top, go to the bottom, and it will delete multiple ones. So it's going to delete Quebec, it'll delete Bob, it'll delete Lithuania, and it will not delete Estonia because there's not enough diplomacy points at that point. So if we say annex provinces, you will see it took out Quebec, Bob, Lithuania. We're down to 990 diplomacy points, and Estonia remains. Okay? So annexing is exactly the same as military, except when you do the military thing, it deletes one province, the first province you can hit. For the diplo annexing, it deletes all of the provinces. It goes down, and you just keep annexing and annexing and annexing until you run out of points. Latvia, yeah, fair enough. Okay. Any questions about this? There's a pretty comprehensive README file that kind of explains it. Genetic algorithm to find a geopolitical optimal strategy, yeah. That's what you'd actually be doing, right? Is finding different combinations and having how much they're worth for not just the cost but the benefit. Like if you want to take the oil fields of some country, that's probably worth more than. Yeah, it is due on next Friday, OTAL. So we are off on Friday and we're off on Monday. So yeah, I was like, if I give it today. Yeah, it's a weekend. And then if I give it on Wednesday, we wouldn't have any classes between giving it and it being due. So it's due in 11 days. Like, you actually have a lot of time to work on this if you got RTX on done. Yeah, it shouldn't be too bad. It's partnered. A lot of it's done for you. RTX on, like I said, you had to do the header files yourself. You had to do the make file yourself. It actually gave you good experience, like working out, structuring a project and things like that. This one, it's taken the difficulty back down a little bit and doing it all for you, and unit tests, tons of unit tests for you that'll tell you where you screw up, and the reason for that is because linked lists are just inherently kind of hard to wrap your mind around. So I turned the difficulty down on the other stuff. No school on Friday or Monday. Yeah. So we will meet here on Wednesday and then the following Wednesday. Okay. Right. So Mr. Singh reminded me of something. I don't know if I'm going to get a copyright strike, so I will show you where to find it and then I will pause the recording. So what is the danger of dereferencing a null pointer? Does anyone know? What is the biggest danger of dereferencing a null pointer? Memory leak? It's not a memory leak. Anyone know? What happens if you if you dereference a null pointer, it seg faults. It will kill your program. But even worse than that is you will get Bret the Hitman Hart mad at you. I don't know if you guys know who Bret the Hitman Hart was, but he was a pro wrestler. He's the best that was, that is, that never will be, right? He'll put you into the sharpshooter, right? So, unbeknownst to most people, Bret the Hitman Hart is actually a programmer. You can see that he codes with his, wrestling spandex on and, headset. There you go. You can see him working in the coding fields in his wrestling garb. And I am being humorous, of course, but here, I'll play this. I'll pause the recording. So so that's the risk, is that you will incur the wrath of Bret the Hitman Hart. So that was a part of a series of promo videos, I think, for like the NES WrestleMania game or something like that. I don't know. It's really funny though. It just shows him walking around in like his wrestling outfit, like doing coding and stuff like that. So the blue color scheme. Yeah, we used to code that way for sure. For sure. This is literally how we used to code. Like I'm actually getting lightheaded just looking at it, but back in the 80s, into the 90s, like this was probably the most common color scheme. Yeah. Like I'm actually getting like a little dizzy looking at this. You can always switch it to dark blue if you want a little less radioactive look. But yeah, I don't know why. That was just very common for that sort of neon blue background. The main reason why people didn't use dual monitor setups, you just have blue bursting into your eyes at every point. So, how did they get to blue instead of black? It must have been like Borland C++ or something. It must have been like one of those programs that just, for whatever reason, they just defaulted to blue. Or maybe... Yeah. It's pretty common, right? They just liked that blue color scheme for some reason. Do the next assignment in blue color scheme for extra credit. It's like Squid Game for programmers. You make a mistake, like we talked about last time, it deletes your whole code directory. You have to do the whole thing in blue color scheme. I just think they're neat. That's funny. All right, that's it for today. Get going again on RTX on if you haven't finished it. And if you have, get cracking on this. And we'll come back with any questions on Wednesday. Okay? So thank you, everyone. Did they used to use void main? I think void main might have been allowed at some point, but it's been int main for correctness for like a long time. Yeah. All right. Thanks, everyone. See you next time.